All right, so let's go to our SolidWorks case now. Get this thing all set up. So we're going to go simulation, and we're going to do a new study. And it's going to be a static study. So we'll green check that. Just working our way down the right-hand side here. So we're going to magnesium alloy. Obviously, that's not concrete, but it has a similar modulus to concrete, and so we use that one because that's the closest thing I was able to find in SolidWorks, so we can compare these things a little bit better. And then cast carbon steel we use for the wheel. So if we expand the parts here, go to concrete floor, right-click, apply edit material. And for the concrete, we said the magnesium alloy, so that's other alloys. So magnesium alloy, and we'll apply that and close. And it looks like the cast carbon steel is actually already there. It was defined, I think, up top here when we had the part defined. So we'll just go in here and confirm we're at cast carbon steel. So we're good there. All right, so we got the materials now to the global contact. So again, it already saw, well, in SolidWorks it says all contacts defined up front are considered bonded. So what we're going to do is change our global contact. Instead of being bonded, we're going to edit the definition and say they're all no penetration. So anything that's in contact, and we don't know actually what is at this point, but anything that is will be considered no penetration instead of being bonded. So we'll green check that guy. All right, so do some boundary conditions here. So fixtures, so we'll do the fixed geometry just here on the bottom. So we're going to go okay with that. And then we wanted the roller slider support for the symmetry. So we'll add some more. So actually, you can right click there. I could go up here. I'll go up here and do a roller slider. So you can click here. All right, we get all those. So check that off. And oh yeah, so we might as well just get this right now so the thing doesn't fly away. I will click this surface and get that one as a roller slider too. Which one do I want? Get rid of this one here. There we go. All right, so we got those defined. And what else? So the loading. All right, so let's go back here so we can see this. So we got the loading. So we're going to do bearing loads, and we need to set this up first a little bit. We're going to go assembly, and under reference geometry, we're going to put a point down so that we can define a coordinate system, because that coordinate system is needed to define the bearing load. All right, so let's go back and do that. So go up to assembly, reference geometry, and we want to do a point at the arc center. So we're just going to click this point right here. Click the edge there. We don't want the face. So delete that. We just want the edge. And we'll go ahead and check that off. So it gets a point right there. The point's needed because to define a coordinate system, which we want next, we'll do that. So go to the coordinate system now. The x-axis, well, we got 0.1. That's the big thing we want. The x-axis, the z-axis, we're okay with what we have. We basically want the z-axis. We want it to be aligned with the axis of our hole. So if it's aligned already, we don't have to do anything else. We can just screen check. It's okay where it's at. All right, so that coordinate system is already active. So we're going to go now into a load. So get the applying the load on here. So we'll come to external loads and bearing load. And so we got that coordinate system. We're going to put it on the, not that face. I'm not sure why that one keeps coming up. It must be still selected. We want the inner surface here of the hub axle. And we'll do, we don't want it the X direction. All right, so these, you can see where the X direction, hopefully slightly, there's the X. Y is up here, so we want to go in the Y direction. And we do 2000. And you can see where the arrows are pointing, so that's the positive Y. We want to go in the reverse direction. And so that's the way we want to go. And I actually can tell you the distribution too. So we want a sinusoidal distribution for the bearing load. So higher at the bottom here, smaller at the sides. Or we want a more of a parabolic distribution. Again, depending on what you're looking at, you can do what you want, but we'll just go with sinusoidal, go with the default. So check that off. And do we have everything? Oh, mesh. All right, so we'll go into mesh and create mesh. And the main mesh, we're going to go with the default here, and then we'll come back and apply mesh control. So let's leave it there for now. All right, fairly coarse as we expect. And we'll go ahead and run it. All right. So the stress, here's the displacement. All right, doesn't look like it's displacing a whole lot, right? No, again, it's the same thing as the last time. All right, this one's, and actually these contours, let's get something more familiar to what we got with, we'll do some smooth contours so it looks a little bit more like SolidWorks here. So we got total deformation in millimeters, so let's compare apples to apples here. So total deformation in millimeters, we're millimeters here. And we haven't quite refined the two spots here yet, but this one's at 3 times 10 to the minus 3. This one's at 2.5. So they're within range of each other. So some of it might be the mesh quality between one and the others, might be the solver. Whoops, might be the solver between the two. But those are looking pretty comparable there, at least with the scales. Again, I don't put too much hope or trust in the colors because those are always based on the scale. So make sure you're looking at numbers when you're doing this. Okay, so let's go back and do our mesh refinement. So we'll come back up here to mesh and right click, and we'll do some apply mesh control. And the surface that we want are this inner surface of this hole, and we also wanted this spot right here. That's where we had the stress concentrations. And we'll crank this up about 3/4 of the way there. And so let's see what the mesh looks like there. So right click and create mesh. Right, so it's a little bit more fine in there. It'll just be crazy. We'll crank it all the way up here. Actually, there's a create mesh. We'll go back here. I'll show you that. There's a create mesh right here. All right, so we'll go ahead and click yes. See what we get here. Yeah, so it's taking out that part. It's not liking what's going on there. So let's ease back on that a little bit. I think what happens is it's getting too fine, so it's not the mesh can't connect with the other parts of the setup here. So we're gonna back off on that a little bit. Let's see what we got going on here. All right, there we go. All right. So we'll run that and see what we get here. Up here and run. Trying to get a face so we can see things going on here. Here we go. All right. So yeah, we got the stress concentration in there. And now, that's the von Mises, what's the displacement? So 3.165. All right, again, we're in range, but there are some differences there. So let's go back to the stress here. And we'll compare that to what we have here. 2.4 megapascals. So 2.7 megapascals. So yeah, so that's the comparison. Just wanted to show you how to do bearing load. If you have any questions, let me know. But hopefully this gave you some understanding of how to do that, and applying boundary conditions, setting up meshes and other things for models in both SolidWorks and ANSYS. So till the next presentation, see you then.